Welcome, my awesome chemistry student, to a video on ions. There's two types of ions. There's negative ions and there's positive ions. Because ions are all about the electrons. In fact, chemistry is all about the electrons. And how chemicals get together and form bonds, well, it's all about the electrons. So the first thing we're going to do is we're going to focus on the ions that make a positive charge. First thing you should know about an ion is its definition, and these are atoms that gain or lose electrons. We're going to start off by talking about cations. I know it looks like it should be cations, but it's not. It's cations. Cations lose electrons, which means it's going to have more protons than electrons, which will make it positive. Remember, an atom had equal numbers of protons and electrons. These guys don't. So a cation has more protons than electrons, which makes it positive. And these guys form from metals. Metals make cations, or positive ions. I lost an electron. Are you positive? Well, the answer to that is yes, because if he loses electrons, then he ends up with more protons than electrons, therefore a positive charge. Ions form because who do they love? Well, they all love the noble gases, and they're going to gain or lose electrons in a desperate attempt to be just like their closest noble gas. Let's look at these two. Sodium. Sodium is desperately trying to look like neon because, see, sodium has 11 electrons. And if it wants to be like neon, who has 10 electrons, sodium is going to need to lose 1 electron so it can feel more like neon. Let's take a look at what's going on. Here I have a picture of the sodium atom. Sodium has 11 protons, and those protons are locked in the nucleus. They cannot leave. I mean, there's no membrane around it, we know that, but you can't change the number of protons. If you did, you'd change the atom. So the 11 protons are stuck there, can't go anywhere else. And the atom, well, it has 11 electrons, which is why the atom is neutral. But if sodium were to lose 1 electron, it now has 10 electrons. And if I add up the 11 positives and the 10 negatives, well, I end up with a +1 charge. So sodium atom is now a sodium ion with a +1 charge, and we write its symbol like that. Interestingly enough, the electron configuration now looks identical to neon. They both have 10 electrons, and sodium is much happier now. Let's take a look at magnesium. How on earth is magnesium going to end up looking like neon? Well, magnesium has 12 electrons, neon has 10. So magnesium is going to need to lose 2 electrons so it can feel like neon with 10 electrons. The magnesium atom has 12 protons. We can't play with the protons. We just can't. It's not allowed. We can only play with the electrons. So magnesium has 12 protons and the atom has 12 electrons. But to feel like neon, it's going to need to lose 2 electrons. Now it has 10. The atom isn't an atom anymore, it's an ion, because if I add those two together, what charge do I come up with? Well, I end up with a +2, but we write it like that, 2 positive, and the magnesium symbol then looks like that. That becomes the magnesium ion, which now has the same number of electrons as neon, and magnesium can pretend it's now more like neon. Here we go, essential chemistry knowledge. This right here is like having to learn your addition tables. On these guys, the noble gases, there is no charge whatsoever. Everybody wants to be just like them. So if we take a look at this, we're going to ignore the nonmetals right now, but if we look at the first column, column 1, these are called the alkali metals. These always have a +1 charge. Lithium, sodium, potassium, rubidium, cesium, francium are always +1, as well as the poser hydrogen. Then let's take a look at the alkali earth metals. These guys always have a +2 charge. Beryllium, magnesium, calcium, strontium, barium, radium, they always have a +1 charge. Then let's look at these three, aluminum, gallium, and indium. These guys always have a +3 charge. The rest of the metals, including these transition metals, you don't know their charge, and I'll get back to explaining those later, except zinc. Zinc always has a +2 charge, and silver always has a +1. So what do you need to know? Everything in column 1 is +1. Everything in column 2 is +2. Aluminum, gallium, and indium are +3. Zinc is 2. Silver's 1. Naming cations is almost super easy. Okay, so the sodium atom becomes the sodium ion, and we write the symbol like that. Then the calcium atom becomes the calcium ion, and we write it with a 2+ charge because it's in the second column. Then the potassium ion becomes like that. Now gold 3 atom becomes the gold 3 ion. Now notice those Roman numerals 3. This is the new modern way to do it, is to use Roman numerals. Makes lots of sense, right? Anyway, that 3 is the charge on the gold. So that becomes the gold 3 ion with a symbol like that. The iron 2 ion then looks like that. And manganese 4 ion
looks like that.
There we go. Makes perfect sense, yes? All right, that's enough of the positive ions. Now, remember, it's all about the electrons. Positive ions lose electrons. Well, I should say atoms lose electrons to become positive ions. It's all about the electrons. Now, let's see how the electrons work for this guy, because now we're going to focus on
negative
ions. Ions that have a negative charge are called anions. Now look, see, A, N for negative ion. That's an anion. See, it says so, A, negative ion. A, negative ion, anion. Anions form from nonmetals, and these guys gain electrons. And when you gain electrons, you become more negative. Let's take a look at this. Fluorine is a nonmetal that has 9 electrons, and it so wants to be like neon, who has 10 electrons. So in order for fluorine to look like neon, it's going to have to gain an electron. Let's take a look at the fluorine atom. How many protons does the fluorine atom have?
9.
That's right. And you can't change those, even though there's no nuclear membrane. They are locked inside the nucleus. You can't do anything with them. Now the fluorine atom then has how many electrons?
9.
But in order to feel like neon, it needs to gain an electron. So now it has 10 electrons. So what is the overall charge now on the ion?
It's negative.
That's right, negative. We write the fluorine ion symbol like that. And interestingly enough, it now thinks it's more like neon because they have the same number of electrons. Let's take a look at oxygen. How many electrons does oxygen have? Well, it has 8 electrons. How many does neon have? Well, it has 10. So for oxygen to think it's like neon, it's going to need to gain 2 electrons. So let's look at the oxygen atom. The oxygen atom has 8 protons. And the atom happens to have 8 electrons. In order to look like neon, you're going to have to gain 2 more electrons. Now it has 10 electrons. So what's the overall charge on this ion? It's -2. And so we write the oxygen ion like that. And now it thinks it's more like neon. Okay, here's back to absolutely need to know stuff. Everything in that column, the noble gases, have no charge. They're always 0. They don't play the chemistry games. And then we're going to ignore the nonmetals for a minute. Just focus on the cations. To review everything in this column, the alkali metals is a +1, including the poser. Then we have the alkali earth metals, and everything here is a +2. Aluminum, gallium, and indium, well, they're always +3. The transition metals, well, you have to be told those except for zinc and silver. You do need to know those two. Now, let's focus on the anions for a minute. And those other light blue ones, well, those behave kind of like transition metals. But here's what you need to know. The halogens. But I don't mean all of the halogens. I just mean the first 4 halogens. These guys are always -1. That's fluorine, chlorine, bromine, and iodine. Then in the oxygen group, well, here, these guys, not all of them, but just the first 3 are -2. That's oxygen, sulfur, and selenium. Then in the nitrogen group, I don't mean all of them. I just mean the first 2 have a -3 charge. And then in the carbon group, the only ones I'm truly worried about is carbon itself, and it has a -4 charge. Those are the absolute need-to-knows for the rest of your chemistry career. Now, naming anions is not quite as easy as it was to name cations because we have to change the ending. Fluorine becomes fluoride, chlorine becomes chloride, and bromine, bromide, iodine, iodide. Then we have oxygen, which then becomes oxide, sulfur becomes sulfide, and selenium, selenide. Then we have nitrogen, which becomes nitride, and phosphorus with phosphide. And last but not least, carbon, which then becomes carbide. If you notice, they all now end in "ide" when they are an anion. And they'll never be a cation, by the way. These guys are always negative, always. Up next, we're going to start taking these ions and putting them together to make ionic compounds.